So let's continue on with this example. Again, we created this Rushton impeller system. We used a canonical tank. That is, we gin this tank up directly within the DMT. I'll show in again in the next video how to actually import your own tanks, but here's where we are with this simple system. Let's show how to add particles and probes. So particles are imported again from the model view. Create particles. And what we do here is we specify a box, a three-dimensional box, wherein we're going to either inject or remove particles. And we specify this box by using 2 points, the lower corner and the upper corner. So the lower corner is the most negative, or the lowest of all the points of this box, in both x, y, and z. I'm sorry, in all three x, y, and z. And the upper corner, as we prompted for next, is the most extreme, in both the largest x, y, and z value of this box. You can see we can define this three-dimensional domain just using these 2 key corner points. So I'm going to define this box. I'll put it at the bottom of the system here. So I'm going to make this the lower corner extend from, let's say, 0.2 to 0.01 to minus 0.02. So this bottom corner here goes from minus 2 centimeters. So that's going to be somewhere, again, x is minus 2 centimeters, 1 centimeter, and minus 2 centimeters. So it's in this lower corner down here. And I'm going to have that extend to an upper right-hand corner of 0.02. We'll make it 0.03, and we'll make it 0.02. So again, that's the upper right-hand corner of my box. That's the most positive or largest extrema in this little box source or sink. So again, I now click through that. This is going to be a particle box, so I put the P in there. And now I need to tell it, is this box a sink, a source, or a dump? So those are the 3 options. We can either have a particle sink, and a sink, as it suggests, is a region wherein all particles are removed. That is, if a particle enters this box, a particle disappears. Okay. A source is a constant source of particles, and we specify a particle concentration, and that the particles within the particle concentration in that box is maintained at that set value. Think of like a CSTR. This is a continual source of particles entering the simulation space at this position, with the concentration specified per user value. A dump, as the name suggests, is a one-time dump of particles with a user concentration at a user time. Okay, so if I do dump, put in D, I specify the density of the particles. Let's put in 100,000. This again is in particles per meter cubed. So I'll say let's go for a million. Why not? The code can handle it. And the time at which I want this dump to occur. So let's say I want this dump to occur after, say, 2 seconds of impeller spinning. Let's say that's how long it takes for this thing to get somewhat equilibrated. So after 2 seconds, I'm going to dump a number of particles that corresponds to a concentration of 1 million per cubic meter in the volume I created. And so there it is. We have this little volume we created here. We're going to dump particles there. The concentration is going to be 1 million particles per meter cubed. Now this volume is much smaller than a cubic meter. It's just a few cubic centimeters. It's just a few centimeters on either side. There's not going to be a million particles, but you can put in large concentrations and simulate large numbers of particles without any problem. And it's of type dump. That's type 2. We're going to dump particles We're going to dump particles at time 2 in the simulation. I can add other particle dumps and sources and sinks as well. Let's create another source or sink. I'm going to mirror this. I'm going to make it again W minus 0.02. I'm going to make it near the top of this flow domain, and so that top has a value of around 80-ish centimeters. So I'll make this one go to 0.77 and then minus 0.02. And I know I'm being kind of fast with these value import, and you'll get fast at it too. I mean, you'll just get a sense of where these things should fit in your system and where we should put these domains. But again, so as the lower left-hand corner, it's going to start right around here. My upper corner is going to go, again, mirroring what I put in previously, is 0.02. I'll have it go up to, let's go to the top, 0.8, and then 0.02. Again, this is a particle box, so I'll put in P. this is going to be, I'll make it a sink. So what this means is that if a particle, I can specify a density, but the density is meaningless because, again, this is going to vacate any particle that enters into that space, and I'll have that on from the beginning. So if a particle ever enters this space, it's gone, okay? This is a particle sink from time 0 onward. Now, that time 0 doesn't mean much because remember, these particles, this source, this dump isn't starting until 2 seconds, so it doesn't matter that this thing's vacating particles from 0 to 2 seconds. There's no particles to vacate. But fundamentally, it will always be a particle sink. And if any particles meander up there, they're going to disappear. So again, back in the simulation tab, I can specify my particle diameter and my particle specific gravity. And they're gonna be dumped into the system from that domain at time equals 2 seconds. Okay, and they'll be vacated up here. So if I don't have this thing spinning fast enough, they're never going to make it to the top. And that's fine. They'll just rattle around in the bottom. But if I don't have this thing exceeding NJS, and I don't have a high enough impeller frequency, they may never realize a cloud height sufficient to vacate. And that's fine. Those are just the physics of the system. So one thing I may do, though, is if I want things to rise, if I want them to be bubbles, I just change the specific gravity. You know, if I make these things have a specific gravity of 0.001, this is no longer sand, of course. It's now bubbles. Okay, so I have bubbles entering the system from this lower domain. They're going to rise in response to buoyancy, and they're going to be scattered across the cross section. But any bubbles that enter into that region are going to vacate, right? And so again, it was kind of weird to put a particle dump at the bottom of the tank. And we have to kind of hope that they're going to go up there given our impeller speed and such. But again, if they're bubbles, then this may have been an appropriate morphology. Whereas they're going to start from the bottom, rise through the flow field, and eventually get sucked out through this sink. And that's particles. It's as easy as that. So again, we just right-click. We can either save the files, we can run locally, push to the cloud, and do the analysis. It's that simple. Oh, and one key point here. We can always model these as simple massless tracer particles. So if we give these things a diameter of 0, or if we give them a specific gravity of 0, the DMT will still treat them as particles, but at this point they're non-inertial, right? They have no mass, they have no diameter, they just become tracer particles. So what it means is that at time equals 2, there's going to be a dump of essentially non-inertial tracer particles in this volume here. And as they spin around in the system, they'll get drained as they eventually rattle through and approach and enter into this vacating sink. But they won't be influenced by gravity. They will just float around in response to the instantaneous and local flow field. And note, of course, consistent with convention, gravity in this case points in the negative y direction within the context of the DMT. So those are particles, both non-inertial tracers, which are set up just as inertial tracers might be. But for non-inertial systems, we say 0 diameter, 0 specific gravity. For systems with mass, we go ahead and give them, again, an actual diameter, and give them, say, a specific gravity, and have them be moved not only by the fluid, but also by gravity. And that's particles. So again, we run in our canonical way, and it's just as easy as that. Okay, I'll end this one, and we'll be moving on to probes and more advanced modeling topics in the next video.